Anyway, hi, I'm Andrew Harris. This is Alex Yakushev. We're here to present a talk that we've entitled Almost Zen, Reflections on 4 Years of Scala in Practice. First, a little bit about ourselves, who we are. We are engineers, you might have guessed. We've been writing Scala for a few years now. We started out at a startup called StackMob. It's a backend as a service provider for mobile API developers. I had that like down pat for a while, but it's... we've been working in Scala since about 2011, myself 2012. So if you're counting, that's about circa Scala 2.8 and circa Scala 2.9. The company StackMob was acquired in December of 2013, and we've been writing Scala inside of PayPal ever since. So disclaimer, short disclaimer, you can see at the bottom there. These are our opinions. They are not necessarily reflective of those of PayPal or eBay. Yay. Legal advises us to say that. It's fun. So what does our agenda look like today? We're going to go through some old code of ours. It's going to look totally sweet. Hopefully it'll blow your minds at how bad it is. We'll progress through our code writing style and show hopefully how we've improved a little bit over the years. We'll transition then into, well, we'll do an overview then of some of the neat things we've learned. We'll do a deep dive into one particular thing, which is something we've struggled with, which is Java to Scala interoperation. And then we'll offer some closing thoughts, which we hope will be useful to you going forward. So without further ado, I'm going to transition to Alex here, who will take us on a journey. It'll be beautiful.
Thanks, Andrew. So as Andrew mentioned, I started writing Scala in 2011. I joined a new company called StackMob. And I had absolutely no prior experience in Scala to that point. I had quite a bit of JVM experience, and I wrote a lot of Java before that. I knew nothing about Scala. I joined, and my boss told me, "You write Scala now." So I tried. And as many of you who might have come from the JVM world, from the Java world specifically, and got introduced to Scala, your first Scala commit might have looked something like this. So what do we do? I mean, when we try to learn a new language, we try to draw parallels with the old language, right? So how do you declare variables here? Well, you just say var, and you just check for nulls like the way we do in Java. So it kind of leads us to the questions, how many things are actually wrong with this code? And the answer, of course, is nothing. It's code that works perfectly fine. It doesn't actually throw null pointer exceptions, it's pretty happy. We could deploy it to production and be happy with it. But of course, now that we've become Scala engineers, we can talk about all of these possible things that are wrong with it almost on every single line, right? So you have the first line where we're declaring a var that could easily be a val. We're checking for nulls in a Java-like way. We could totally wrap that into an option. The third line is probably the worst, where we're doing an explicit return and returning a null from a Scala function. It's a total no-no. Then the next line, again, we have a var that could be a val. Then again, we're checking for nulls. We're throwing. That's something that some people do in Scala code, but we actually, nowadays, we would prefer to wrap that into a try and not explicitly throw from a Scala function. And then the final line looks okay, but it actually could potentially be null because it's calling a piece of Java code that could return a null. So that's actually a lot of things that are wrong with it from a Scala perspective, right? So we learn these things, and just a few short, I was going through a commit history. Just a few short months later, the code looks like this. So it's actually, given this just a few months of learning Scala, this is actually not too bad. In fact, the only thing that I would change nowadays, I would actually flat map over the options instead of doing the match statements like that. And flat mapping would get rid of the case nones to none, and that would save us a couple of lines, and it would look a little cleaner. Yeah, that's pretty good progress for 2 months. But looking at this code, there's something that struck me as a little bit weird, and it's why did we make these parameters implicit? And I looked at the code and I thought, well, was there a really good reason to make these implicit? Maybe there was some deep thinking about this, But really my guess was that we learned about Scala features, we learned about implicits, and we thought we must use implicits in our Scala code. So we found a place to use it, and we did, because Scala features are a drug. Since we're here in Amsterdam, we just have to ask, are drugs bad for you? Is this really a bad thing? Yes, the answer, of course, is that you could have different opinions about it, right? So you could have totally different policies, and there are a few things that are never going to work correctly. There's complete criminalization that's going to always blow up for you, or you could be very liberal, and the extreme of that is also extremely bad. So with the real liberal approach, we actually need some regulation. So what kind of things can we regulate? Remember that we're actually talking about Scala features, not actual drugs. So this brings us to the next project that we had. In early 2012, by early 2012, we hired a few people that were really into functional programming. And one of them, as a weekend project, wrote Scaliak, which was a client for riak in Scala. This project is still available, actually, open sourced on GitHub and in the StackMob repo, but I'm not really advertising it because it's not maintaining it longer. So let's take a look at some of the code that was in Scaliak. So this is now, this is less than a year into us starting with this new language. And you can see we've gone to the complete extreme functional case, right? This is using the I/O monad for a very simple thing. It's actually just fetching the result of a bucket, then it's printing a debug statement, then it's doing a delete on that bucket and printing another debug statement. If you're not familiar with why you have these pure I/Os, this is a use of the I/O monad, which is the functional way of representing a side-affecting I/O process. What you're doing here is you're saying, I want to do these things, I want to do this I/O, but don't actually do it. This way, your function can remain completely pure. So to say that it's always going to be side-effect free, it's never going to blow up, even if your actual I/O is completely broken. The result of this function is always going to be consistent, right? It's never going to be affected by what the state of your hard drive is or something like that. That is to say, until you execute a function on the I/O monad called unsafe perform I/O, which is the way that the functional world has of interacting with the real world, right? So this is this bad? Well, this doesn't look too bad, right? The only thing here is if you had somebody that was coming on and learning about what your code base looks like, you would want to explain to them why do you need to have this overhead just for some simple print line statements. But we were pretty happy with this code. We published some blog posts. We got some, we tweeted about it a bunch, and we got some, nice feedback. People saying stuff like this, oh, this is the smartest way of fetching and deleting a key from a key value store. Except I think the guy that wrote this meant it to be read like, oh, this is the smartest way of fetching and deleting from a key value store. Yeah, I think the guy was being sarcastic about this. Not everybody is going to be appreciative of having so much overhead just for some simple operations. So going back to this, remember the very first slide we had nulls and vars, and that was perfectly okay code. This is the other extreme example, right? This is using the I/O monad. This is perfectly okay code, but you do need to communicate to your team why it is that you want to use I/O, why it is that you want to have pure functions. What is the benefit that it's giving, that you're getting from using this style of code? Why is it worth the overhead of thinking about all of these, having to wrap your simple debug statements into I/O monad, right? So this brings us to the next project, which was Scalamachine. It's another project that started as a weekend thing, as most things do. This is also still available of open source, and it's support of Basho's web machine, if you've ever seen that. That was an Erlang project that simulated the REST HTTP flow they had a big diagram of how the life cycle of an HTTP request looks like, and they basically implemented that step by step in Erlang, and then one of our engineers took that and ported that into Scala. The tagline for web machine was, you can call web machine a REST toolkit if you like, and we won't argue with you. So it was a little tongue-in-cheek, and my tongue-in-cheek thing was, for Scalamachine, when monads don't do it for you, you have to go with monad transformers. If you're not familiar with monad transformers, the need arises pretty quickly as soon as you have monads. If you have something like this, if you have a list of future t, what you actually want to get as a result is a future of list, right? Like if you're spinning up a bunch of futures to do a bunch of background tasks and putting that into a list, it's a little bit cumbersome to deal with as a data structure, as a list of future t's. What you actually want to get as a result is the other way around. You want, in the future, you want to get a list of results, right? That makes a lot more sense. And you can imagine that writing this particular function, going from list of future to future of list, is fairly simple, right? You could probably write that out in a couple of minutes. But then, of course, you're engineers, and you're going to say, well, I have a list of future t to future of list. Can I make that a little bit better? Can I make that a little more interesting? Can I go between, let's say, options of futures or IOs of futures? And since IO is a monad, you will have futures of IOs and IOs of futures. I mean, that's just life. So what you end up is things like this. This is real Scalamachine code. Please don't ask me what this does, because it's literally Greek. It's it's using lambdas and alphas in there. This is going between some monads and some other monads. Particularly, I think the res monad, which represents the result of a computation. So the idea behind this was to actually help the users of the library, of the Scalamachine library, go between different monadic types, right? The problem I would say with this is that now if we were still using this, and I would probably be the maintainer of this library, and I would have to go back and figure out what this actually does, and I don't want to do that. This looks really painful. Also notice it's using an internal copy of the Scala Z library because we were so ambitious at the time. We were using features of Scala Z that weren't actually available. It was like forked from a developed branch of the Scala Z, and going when Scala Z actually released the features that we wanted. Going back and fixing all this to be in line with the main Scala Z branch was a big pain. So now we've seen the internals of Scala machines. What was it like to use it? Let's say that we have a fairly simple use case where all we need to do is take a parameter from an HTTP request path, log the value of that parameter, then we call a function, and then we log it again, and return the JSON representing the result of that function call. This is a real piece of code that existed in our code base. This looks just terrible. Everything here needs to be lifted inside rec resp state res t monad. I think this would be even hard in Dutch to pronounce. Every single line here is basically the result of a programmer trying to figure out how to get things into the right sequence of monads. So remember when we had the difference between future of list and list of futures? This type actually represents several, I think, nested monads that had to be juggled just in the right way for everything to work out. This also combines exception handling into the flow. There you can see a validation T in there somewhere. And then there's a couple of applied transforms. I think one of them applies to the validation part and the other part applies to the actual function call. and then you have to do some kind of magic. That's the whole flatten A thing, or whatever that line is. It's pretty gnarly. Every single line here, you're just fighting the type system. You're just trying to figure out how do I get the right type. And even though the idea behind the type system is that it gives you safety guarantees, when you're fighting it like that, you're actually hurting your productivity a lot. So we worked to improve this a little bit, and we came up with something like this. This is the exact same function, just later on when we did some improvements to Scalamachine. This looks a lot cleaner. The only problem, and we have explicit exception handling here, except that we have these magical .Scalamachine conversions. This is better, but this is a problem because you have to, when you're bringing people on board, you have to explain to them why your flows have these magical conversions that are fairly involved to explain. Why can't you just, log things without saying .Scalamachine? Well, it's because you're forcing everything you do into this monadic flow. And then notice the other thing is that completing this first val doesn't actually execute anything, right? This is just getting things into the right monad, and then you have to say run to actually execute. So debugging this becomes a little bit more difficult. If you've ever debugged a for comprehension, it's not a lot of fun in a debugger. This makes it like extra difficult because even your log statements aren't really executing where you expect them to be executed. So if we had to do it all over again, right? This is 2013. We're in 2015. What do we have? This is the real code that we have right now. It's cleaned up a little bit to hide away the secret sauce. We use Spray and Akka now. We don't try to support our own HTTP library. It's a lot better. Life is a lot better with Spray and Akka. We generate our Spray routes from a spec and create the Spray route class automatically. Andrew will touch on that later. Most low-level things are handled by actions. So the low-level functions calls that you see in here are returning futures. So we're flat mapping over futures here. There's a little bit of type coercion, as you can see in the case of the cache hit, which is, I think, the third line from the bottom in the comprehension, where you're forcing the result into a future. So this is one small case where you have to do the type coercion. But this is, I would argue that this is a lot easier to explain to somebody why you have to coerce this particular line to being a future as opposed to having that mysterious Scalamachine, or even worse, that rec resp state res t thing. So actually, this is what we write now. Unfortunately, we didn't really have time to get to that at StackMob because late 2013 was right around the time we met PayPal. And our new story started where we're writing code at PayPal. We're trying to introduce Scala to PayPal as a new thing. We're trying to promote Scala usage in different groups. So what have we learned? And what do we teach people at PayPal about Scala? And here's Andrew to tell us a little bit about what we've learned.
Sure. So it's a hard question, right? Like, what have we actually learned from all of this? I can make a self-deprecating joke and say, I don't know what we've learned, but that wouldn't be true. We've actually learned quite a bit, I think. One thing that we learned was to lock down in our, well, not necessarily lock down, but to decide which libraries and patterns we were going to hold acceptable, which ones we were not going to hold acceptable, and why. To that end, we began a modest Scala style guide, which we later released to GitHub. It is quite modest. You can feel free to check it out if you wish. We end up generating a fair amount of discussion offline and on, for each change to this document. In the guide, we tend to prefer functional code patterns wherever possible. Example would be if we have a map that has a single parameter feeding into some function, just give it the function. It's simple stuff. We specify a syntax for common logic flows, like switching between some and none in an option. Reason being that there are like 3 or 4 ways I can think of off the top of my head to switch between those. We just chose one, makes the a little easier to read, especially for new people coming on. We took the somewhat controversial step of banning Scala Z and other similar functional libraries, which may sound contrary to some of the previous points. But what we found, and what Alex alluded to very heavily, was that having these functional libraries proved to be an onboarding challenge to us, in that we had several members of our team who were very motivated to use some of the deeper functional patterns that are available in Scala Z. And then we had people coming onto our team who had very little to no functional programming experience, who found it, myself included, difficult to read some of these deeper patterns. Lenses, for instance, come to mind. They've apparently gotten better in recent Scala Z, but they burnt me pretty easily when I was first trying to wrap my head around them. It also became a maintenance challenge later, even for those on our team who had experience with these, because now we're trying to decode these relatively complex patterns just to maintain our code, just to make like a library bump. It was tough. So we came up with the style guide, and we've decided upon things we want in our code base and things we don't necessarily want. Once we have a unified set of code standards, we're able to generate code to those standards. Alex also alluded to this. We began experimenting with generated code at StackMob, but we never quite got to the step of generating production code while we were there. Now at PayPal, we actually use a code gen pattern for anything that we can hold to a spec. For instance, we support a REST API, a particular REST API that we built internally, and we specified it using the Swagger API specification language, or specification definition. It's all JSON schema. From this, we can generate clients, we can generate abstract resource code that can be then implemented. It hides away a lot of the boilerplate of implementing a REST service. Who knew? We can even generate, we've even taken the step, for instance, of writing a Swagger to Google Discovery Doc format generator so that we can interoperate with other parts of PayPal. It works for us. There are, of course, trade-offs to code gen, and I won't really spend much time on those. It does add a layer of process to your code writing, but we found that to be an acceptable trade-off, and it gives us a net positive. So we find it to be a really great thing to just generate the boilerplate and then implement from there. We caught on fairly late to the Scalacheck game, and if you're not using Scalacheck, you really should be. It's an amazing library. There have been several talks on this. One I can recommend from Kelsey Gilmore-Innes, who's a former colleague of ours. It's a property-based testing library that allows you to generate hundreds of test cases for yourself just instantly, just as a library feature. There were plenty of edge cases that we suspected were present in the StackMob API, but that we had no tests for, or that we had proposed tests for that nobody actually wrote. There was also a ton of the Java style, dummy code data test files and things, and those are just not sufficient. Scalacheck lets you be pretty lazy about your code writing while still giving you orders of magnitude more value than this hand-maintained data. It's really a developer's dreamboat. It's amazing. You put a little effort up front to write your generators to the models that you're using, and then you just get hundreds upon hundreds of tests as a library feature. It's great. And many of the generators are already provided as library features. They're just there for you. If you need a list of option of future of int or something, it can do that for you automatically. It's amazing. The generators also build on one another. So once you've got your initial set of generators set up for your models, you can just extend those when you go to make some tweak or you find some new pathway that you want to work with. It's really expressive. It's a great library, highly recommend. 10 out of 10. We, of course, have to deal with Java, and when I say deal with it, I really mean deal with it. We have to interoperate with a lot of Java code. PayPal is a predominantly Java code base, and it's a reality for us. The parts that aren't Java have Java libraries associated with them, some of which are not necessarily the best, and we found ways to work around those. And so I'm going to spend a little time talking about Java to Scala interoperation, which has been a big sticking point for us. So with that in mind, let's look at some code really quick. What does this particular block of code here do? Give you 5 seconds to think about it. Hopefully it's pretty apparent. It throws a null pointer exception when you try to read it, which is not actually a departure from Java at all. If you try to call a method, or you try to use a feature of something that's not initialized, it'll blow up in your face, which is idiomatic Java. Like, that's just how it happens. There's nothing new here. But we are Scala developers. We have optional types, right? And we can use those to hopefully make our code a little safer. When you're new to Scala and you're reading about immutability, you're reading about type safety, it's easy to forget that nulls can still exist and they can still bite you from time to time. I forgot about them quite often when I was first learning Scala. I still forget about them from time to time. So what happens when we run the following chunk of code? Let's think about this one for a sec. Amusingly, Scala is perfectly happy letting you instantiate a sum of null. This is a known little quirk of Scala. I didn't actually have a good use case in mind as to why it would let you do this until just recently. And one particular use case of a sum null would be reading from a database where you have a key, you retrieve the key, you get a value back, and that value happens to be null. That would be an idiomatic sum of null, correct? That's, in my opinion, it would be. Scala lets you happily instantiate a sum of null. And in this case, what would happen? You would get another null pointer exception because you would try to read a list that isn't initialized. Not any departure from Java, but easy to forget that it can still happen. So let's correct this mistake. Let's actually use a capital O option here. This is using option apply. Option apply correctly translates option of null into a none. And now we at least have a none. We're at least at the point where we're using idiomatic Scala again. But think here for a second. To achieve this baseline of safe interoperation with Java, we needed 2 jumps in understanding. We first had to know that Scala objects are not always fully initialized, despite what the documentation might suggest. And we had to realize that Scala still lets you make dangerous choices, such as sum of null. And those are actually pretty significant leaps for someone who is first going through the Scala documentation and first writing Scala against the REPL, and so on and so forth. So what motivates those previous examples? Often we have to deal with much more nested Java objects, POJOs, plain old Java objects. They rule the day in Java land. They're totally idiomatic, and they are rife with nulls. Nulls on nulls on nulls. It's great. And it can get complicated fast when you're trying to read these. Consider the following example here. We have a Java list of Java objects called myPojos, and we're trying to get to a Scala list of Scala objects. So Java list, Java object to Scala list, Scala object. What do we need to do to make this safe? Well, because myPojos could be null, the first step we have to do is wrap it in an option to make sure that it's not null, so we can actually interact with it. Knowing that it's not null, knowing that it's initialized, we can then convert it to a Scala iterable and map over it, read its internal objects. Those internal objects themselves, since they're Java, could be null. So we need to wrap those in options as well, lift them up. If they exist, we can then feed them into our Pojo to Scala converter, which hopefully is also safe. Hopefully it's not going to blow up in your face as well. You've written it, so you would know. And then from there, if we want to get rid of the nuns in that list, we can flatten it, of course. And if we want to go from an option of list of Scala object, we can abuse the collection API, convert that into a list of 1, and then flatten that list of lists. So it's a thing you could do. This is actually relatively safe. This is a safe pattern of working with Java. So it is. And so long as Pojo to Scala is safe, the rest of this should be safe too. We can sugar it a little bit, we can clean it up a touch, but it's still going to be about 5 lines of Scala. Like we can use the underscore syntax to get rid of some of the named parameters. We can, I've actually contrived the indentation here so it looks a little nicer on the slide. You can squeeze in a few more inline steps if you really want to. But again, it's still several operations to get to this point of safe interoperation. We can break idiom if we want to make it also a little cleaner. Something we've done on our team is take an option apply and made it into an implicit wrapper method. such that we can lift anything into an option by calling .opt. It's not very fancy. It's simply another way of calling option apply. And what it does here is the same thing as option apply. So this would be the same as wrapping my POJOs as in an option. It would lift it into an option and you could begin using it there. It's just a little easier for us to read it in line. But again, still 5 lines, right? This is still multiple steps to interoperate. We can even draw in other people's libraries. Like you can draw in Scala Z, which has the object maybe, which is similar to option. I won't say it's equivalent because it's not. It's similar to option, but it also forces you as the developer to acknowledge that you're dealing with nulls. They even call it from nullable. And it's very similar to working with the option in this case, and we're still juggling nulls, right? And this is still pretty awful. Does it get better? You want me to say yes, right? It doesn't really. You're still going to be juggling nulls, and that's a reality of working with Scala, and it's something we've had to wrap our heads around. I'm going to caveat this because it does get better in a couple of small cases, and you'll see them directly after this. What you can do and what we've chosen to do is pretty much lock down in one place in our code base where we have this interoperation code, such that when you go to write your Scala, you can just call a def and it will give you as close to the Scala idiom as you can get. And this is an example of something we've done here. We have a whole segment in one of our products that does exactly this Java to Scala conversion. It's not perfect, but it works for us and it does help a little. And it's something you can definitely take away. You can lock down where your interoperation code lives. It can get better if you control your API entirely, which is kind of nice. For instance, with the Jackson module for Scala, it can actually do a lot of this boilerplate work for you, giving you just pure Scala objects back. And dealing with nulls in ways that you specify. You can still get nulls in your Scala objects this way, but at least you'll know that it's a configuration parameter and you've made that active choice. The particular flow here actually maps over tries, just regular Scala tries. This is actually used in our code base to do some of our JSON handling. It works. This is a thin wrapper around the Jackson object mapper. You can also, if you're forced to use someone else's client, take the toolbox approach and just go and reverse engineer the whole thing. We had previously been using a blocking, thread unsafe, it relied on thread locals, Java client that had been published for us to consume an interface that we needed inside of PayPal. That happened to be, we learned later that happened to be tied to an object model definition. And when we realized that, we figured, hey, we've got a spec, we can generate on that, right? We can generate our own client. And so one of our more intrepid team members set forth to do exactly that. He used that object model to generate a pure Scala reimplementation of the Java client that we've been given. It's still a work in progress, but it does give us a non-blocking, thread safe, even actor aware, you can see it here just passing the sender reference, actor aware client that we can use for this interface. Again, this is not new. It's totally in just the general developer toolkit, but it's something that has worked for us, and we can recommend this as a solution, as a pathway to interacting with Java clients. When they don't work as well as you want them to. Just make them work. You can then make them work how you want them to. Each of these topics here, this is more stuff that we've learned that we could do a mini talk each on. For the futures line, we initially had some misconfigured thread pools, and we were very confused over all the blocking we were seeing and why all of our cores weren't being utilized. For the Akka line, we similarly needed to read the fine manual for routers and dispatchers to know how we should be configuring them. Similarly, we were wondering why we weren't pegging out all of our cores. And when we actually figured out how to get it to peg out all of our cores, we saw a multiple-fold performance increase, which you can probably imagine. Dependency convergence is a big problem, especially in large frameworks. Even some of the more common frameworks you might be accustomed to have small pieces of dependency mismatches in them. I would encourage you to turn on strict dependency convergence in your build tool of choice and see what happens. It's pretty fun. Code generation, as I said, has its drawbacks. It is a process thing. You can resolve it through documentation and effective training. JSON serialization perf testing was something that we took upon ourselves. We tested about a half dozen different JSON libraries about a year ago. And to our surprise, Jackson, in our tests, which were they were contrived for our use cases. In our test, we found surprisingly that Jackson was the most performant of all of them, which I guess in retrospect is not all that surprising because it's a well-tested library. It's a strong library. It's good. We need to actually go back soon and test it again to make sure that Jackson is still the best choice for us. I'd encourage you to make similar tests yourselves. And we could probably trade a lot of war stories about navigating a large enterprise Java ecosystem as a minority language. It helps that we're a minority JVM language, at least. We can kind of masquerade as just a Java thing in some places. But at any rate, we didn't have time to go into these, unfortunately, so sorry. So in conclusion, what do we have to offer you? You don't necessarily have to commit to either a functional or an imperative style. There is a happy medium between both. We think we've found a medium that works for us. That medium may differ for you and your use cases. Scala enables like a whole wide variety of how functional or how imperative you want to be. It's a pretty cool language that way. Scaliak, enough said, use it. If you're not using it, you're doing yourself a disservice. Get into it, it's great. Hide away your boilerplate, hide away your interoperation code, stash it into single packages or single spaces, single objects, whatever, and you'll never have to see Java again. It's great. But most of all, if you take away a single point from this whole thing, it's to make sure that your team has a shared understanding of your code base. You saw the examples earlier with Scalamachine and Scaliak, the heavy use of some pretty deep functional patterns. That was not the only example we found in digging through some of our old code, and I still have trouble wrapping my head around some of it today. If you have a shared understanding and you communicate that well to your team, you will be able to onboard people more effectively. You'll be able to maintain your code base better now and better in the future, and you'll just have a happier life. Happy code, happy life, right? So with that, I would open the floor to questions. Thank you for listening to us here. Take questions here. We have about, 8 or 9 minutes, I think? About 8 minutes. Questions, one in the back. Do we have microphones? Do you want to be the microphone runner? Yeah. Sweet.
So what are you using for your code gen? I know there are a few things like...
Oh, I totally glossed over that. Swagger code gen, sorry about that. Because we've chosen the Swagger API format, we can also use the Swagger code gen tools, which themselves, kind of to our chagrin, have transitioned to Java in their most recent versions. One of the downsides that I didn't go into of CodeGen is when you tweak the CodeGen utilities to fit your use cases, you can easily become divergent from the main line. And we've actually done a pretty poor job of that on our team of keeping up with the Swagger mainline, such that we're actually pretty far out of spec right now with even the 2.0 still Scala line, let alone the 2.1 like Java line. So if you pursue CodeGen in any format, I would encourage you to stay up with whatever the mainline is doing too. Otherwise, you can hit a maintenance problem later. But yes, TLDR Swagger CodeGen.
Also, I was pretty bummed out by them switching to Java.
Yeah, I know.
Pretty much all the custom stuff we would have to rewrite if we wanted to merge back.
Yeah,
so that kind of sucks.
It would be unfortunate.
Yeah. I saw you in the back, but this guy's close.
It's Alex's choice, so.
I was wondering, how did that process go by basically determining what to do with Scala and what not to use, like not using Scala Z? Was it like one meta meeting or something?
I would say it's the result of several meetings, several discussions over the course of multiple years. It's been a very organic process for us. When we came over to PayPal, we definitely had time to sit down as a group and say, what do we want to do? And that was actually kind of how the style guide began as well. We made the choice early on to not touch Scala Z for a little while. Like we'd been burnt a couple times by it. This is not a criticism of Scala Z, it's more criticism of ourselves. But like Scala Z is a great library for what it does. I'm not meaning to trash on Scala Z here. But we did not want to have to worry about like hard functional patterns in upcoming code. So we made the active choice, for instance, to not use Scala Z for a little while. We actually have a couple people on our team who've been experimenting with Scala Z over the last couple months in a separate project, which is fine. Like that's what they wanted to do, and it's their project and they can work with it. So
also going back to the question a little bit, we keep having these little small meetings about if somebody brings up some kind of functionality or something that's slightly controversial, or they say, listen, we're doing it, this way all over or we're doing it in several different ways all over the code base. Let's come to an agreement and just from now on do it one way, And so we have a meeting or we debate it and we vote on it and then it's settled. And there's such a satisfaction, even if you lose, like you're like mad for a little bit because they're not doing it my way. But then there's such a satisfaction next time you write the code and you don't have to think about which way you're doing it. It helps a lot. Like it helps everyone, even the people that didn't really agree with the decision.
Yeah, like I wanted to use option fold to do the sum and none matching, but I lost that argument. Sorry, I saw some hands go up over there. Again, Alex's choice. Yay.
How big is your team of Scala developers and how big are the groups that come together to discuss the style guide?
The group is the entire team. Our team is, what are we, like?
We're 15-ish?
15-ish? Yeah. We're a relatively small team.
Yeah, it was between, at times it was maybe as big as 20, was it?
Yeah, that sounds about right. Yeah, so call it 15 to 20. And we are all involved in these discussions, from the more functional folks to the more heavy Java background folks to everything in between. Everybody has a say in this. When it comes to a vote, everybody has a vote. They're all equal votes. It's relatively egalitarian, and we like it that way. So.
You said that you get a lot out of the usage of Scalacheck.
Yes.
So how do you come up with the rules? Do you use the standard? Do you extend them? And how do you add new rules if you need them?
So to explain Scalacheck very slightly, it is a property-based testing library. Shout out to Rickard Nilsson. Woo! It's less of a rules thing and more of a what should your data look like sort of thing. So an example would be like an address. Let's say you have a user's address. An address has like lines and it has a postal code and so forth. All of those have forms, right? So the line could be a string, the postal code could be numbers and letters, etc. You would specify what those inputs should be and what the constraints on those should be. And the Scalacheck library generates instances of those based on its internal weightings of things. It does prefer edge cases. Like if you can have an empty string, it'll put an empty string in there. It'll put control characters in there. It'll put high Unicode in there because it can. If you have an integer, it'll prefer like maxint, minint, 0, 1, -1. It tends to prefer the edge cases, but it will also give you random stuff in between. So it's less about us coming up with rules and more about us communicating to it, like in code, what our data ought to look like, and then it under the hood picks out or like decides on these random generations. Does that answer your question? Okay. It's great. Definitely check it out. I think it's scalacheck.org is the website. Google for it. It's great. Do you have a tool for the style guide? Yeah.
Yes, it's checked automatically by, what is it called?
Scala Style. Scala Style. Yeah. We have it as an SBT plugin, and not all of the rules that we enforce as a team are in the Scala Style XML because either we haven't written them or they can't be enforced through whatever mechanism. But we do have this enforcer, and it does actually fail the build if any of the rules are broken.
And the things that aren't enforced by Scala Style are enforced by code review.
Yeah.
So everybody knows the guide, right? And if they see something out of place, they fix it, and it's just like a no-brainer. Yeah. The Scala Style plugin.
Yeah, we didn't write that.
Yeah. Our rules, yes, they are on public under github.com/PayPal/
Scala style guide. Yeah, we'll put the slides up after this and whoever's hosting slides. So, yeah. They're also, like, the Scala style XML is pretty well formed as it is. If you just install, like, if you pull up the Scala style documentation and download their sample XML, it already has pretty sane defaults. So if you just run it against your code, like, we found a bunch in our code base the first time we ran it. We're like, oh, we should probably clean this up a bit. It also, like, for sections that, for instance, it does, for instance, like cyclomatic complexity checking. If you have a method that's too thick, you might have no other way to do it than that, and it lets you turn off the rules for specific instances, which we also enforce because it forces us to justify why we're turning off a rule. So, I think we do one more question, I think. Possibly 0 more? Oh, one in the back. There we go.
Not really a question, but rather a comment. We did checking last month, and Jackson is still the best.
Still the best. All right, cool. Okay, good. Work
Thank
off
you.
our shoulders then. Thanks. All right, well, I think that's it then. I think we're at time. So thank you all very much, and enjoy the rest of the conference.